Hello students, today I'll be talking on circuit analysis technique using Thevenin equivalent and Norton equivalent. Okay, so if we look at the relationship between Thevenin and Norton equivalent, where in Thevenin equivalent, well, the circuit is represented using a resistance or equivalent resistance in series with the voltage Thevenin. Okay, and if we look at the Norton circuit, the current source is now in parallel with the Norton resistor. So what we can see is that the resistance in Thevenin is that in parallel when it comes to Norton circuit. Okay, so here is the relationship. To go from Thevenin equivalent to Norton, we can use source transformation or either way. Okay, so for example, IN Norton current in here is equals to V Thevenin divided by R Thevenin. So if we divide this V Thevenin by R Thevenin, we get the current source. And then of course, Rn and R Thevenin are the same, okay? So the reason for doing this one is that if we have a large network, we can represent using a single Thevenin equivalent circuit or Norton equivalent Norton circuit or Norton equivalent circuit, because we don't need to know every bit of the circuit. For example, if we have say a large network here, okay, whatever, and then if there is any fault here or whatever, if we want to measure here, we don't need to see what happened on each circuit because we have to stand here, okay, and then we only want to see at this fault location. This could be 100 kilometer, 10 kilometer, doesn't matter. Then to do that one, we can represent this one using a single, Thevenin circuit from here. Okay, so that is what is called R Thevenin. Okay, and so, well, how do we do this one in practice? Well, to do that one, there are a few steps to follow. Okay, for instance, for network containing only independent, if we have independent only, then we can deactivate all the sources because we need to calculate the R Thevenin or resistance Thevenin equivalent circuits. Then replace the voltage source by a short circuit and replace the current source by open circuit. So there are two rules, okay? Then from that, we can calculate the equivalent resistor as seen from the terminals. What it means is if we have a circuit like this, okay, whatever here, and then if we have another current source, and then for example, if we have to calculate here, then we can shorten to find R Thevenin because we only need the resistance. We can short this one so that this is becoming in parallel with this one. And then we can leave this one open, as it says open circuit. Then we have to, for example, if this is R1 and R2, then R1 times R2 divided by R1 plus R2 will be R Thevenin, okay? Because this becomes in parallel with this one. Okay. So this is just the same. And then from that, if we have dependent sources when we have like this symbol, okay, whatever. We have to deactivate all independent sources as we discussed it, and then follow this rules, and then apply a test voltage or current source to the terminals. We can apply the test voltage, and then from that we can calculate the R Thevenin, which is equal to the ratio of this test voltage, the resultant current. Okay. So let's see one example. How do we calculate this circuit using a Thevenin equivalent? Okay, sorry. Thevenin equivalent. Well, we can decide to determine the Thevenin equivalent network between A and B. Okay, we can follow easy steps. find the voltage Thevenin. Well, we have to use, sorry, this has to be nodal. We have to use either nodal analysis, either here, for example, okay, or mesh current. Mesh current is like this, okay. We can decide which direction, or you can decide this way as well if you want, whatever, which direction, okay. So then we can restructure in matrix form, because if the equations are more than 2, we can, if the equations are less than or equal to, you can use simultaneous equation to find, you know, current or the voltage, whatever is required. But if the equation is more than 2, then we can use matrix form. Like matrix form is this by this. Okay. So as you can see here, yeah, let's have a look whether we'll have if we need the matrix form. Okay, but that's the generic formula. So then we can use matrix inverse to find the vector current. Okay, and then from that we can calculate the voltage Thevenin between A and B. That the voltage across this and this. Okay, across A and B, which is this one. So this voltage plus this voltage. Okay. What I forgot on here is this voltage is supposed to be 18 volt. Okay, because it's given here. Okay, so let's have a look. So we have voltage sources, that is independent voltage sources. Okay, but then from that, how do we calculate? If we need to find the matrix inverse, then we can follow this instruction as well. We have to first calculate the determinant of the matrix. Okay, and then from that we can calculate adjacent of the matrix or the cofactors, and then from that we can just calculate the inverse matrix is equals 1 over determinant of the matrix times adjacent or the cofactors. So this is all to do with the V Thevenin. To find the R Thevenin, as we discussed, we have to remove all the sources. Just short circuit this one, short circuit this one, okay? Short this one and short circuit this one. And then replace them, short circuit, and then replace the current sources if we have with an open circuit. So we don't have here any current source, but we can leave as open if we given. Then we can calculate the equivalent resistance. Okay. Let's see now. So obviously this is 18 volts. Okay. So in here we can create, the first step is create the equations. So let's use the mesh analysis. Okay. So for example, in here, if we call this one IA, so IA times 12, that is 12 IA plus, okay, I will start to let me just erase this one. Okay. Sorry to be back here. Okay. If I start equation 1, for example, okay, on here, so 12 IA plus 6 times IA. Obviously, I have this one minus IB. So 6 times IA minus IB. Okay, and then from that, we have 24 voltage source. Okay, what I could do is then I can just plus 24 volt, just to ensure the plus voltage is here because we're going down. Okay, and then from that we have here, okay, 16 volt, but this sign now is changed to minus plus. Okay, so I have to put minus 16 volt. Okay, and then we make a loop so that I have to make equal to 0. Okay, so this is a mesh 1, and then mesh 2. Okay, across this one, IB. So we can start with, where do we get IA on here? Okay, for example, in here, 6 times IB minus IA. 6 times IB minus IA, because IB is this 6 going this way, so this way. So 6 times IB, but because IA is going down, so minus IA. Okay, then plus 8 times IB minus IC, because IC is going this way. So 8 times IB minus IC. Okay, and then from that we have 2 times IB. 2 times IB, and then from that I have 18 plus 18. Okay, and then I have here minus 24. That is equal to 0. Okay, so and then at mesh 3, I can start with this one. From here, 4 times IC plus 3 times IC minus 12 volt. Okay, whatever, sorry, I just put voltage on here, but that's fine. We can just cancel for now, this obviously. Okay, and then plus 5 times IC. 5 IC. And then on here I have plus, sorry, 8 IC minus IB, because IB is going this way. 8 times IC minus IB. Okay, it's equals to 0. So from that we can rearrange. Equation 1 will be, we can rearrange in the form of I A IB IC. Yeah. Okay. So now let's do here 12 IA and then plus 6 times IA 6 IA, so that 18 IA. IA. So I have to be neat. Okay, so 18, all right, on here 18 IA. Okay, and then I have 6 minus 6 IB. Okay, minus 6 IB. Okay, what else do I have here? I don't have anything. I don't have any IC. So 24 minus 16, which is 8, plus 8. Then I can take out that side. So that will be. So it will be minus 8. Okay, because 24 minus 16 is 8. But if I bring 8 into that side, minus 8 volt. Okay. Now on the mesh 2, I can do this way. Minus 6 IA. Okay, minus 6 IA, 6 times minus IA, because I'm just reforming to IA, IB, IC structuring. Okay, and then plus, obviously 6 IB I have here, and then plus 8 IB, which is 14 IB, plus 2 IB in here, 16 IB. Okay, so plus 16 IB. And then on here, what else I have? I have IC, minus 8 IC. Okay, minus 8 IC. Okay, is equals to how many voltage? So I have here 18 minus 24, which is minus 6. And then if I bring the minus 6 into that side, then it will be 6 volt, okay? And then mesh 3, we don't have any IA, okay? I think we have IB on here, minus 8 IB, minus 8 IB, plus, is it plus or minus? So let's, 4 IC plus 3 IC is obviously 7 IC, they are in series, okay? And then 7 IC plus 5 IC, they are 12 IC, and then plus 8 IC, which is 20 IC, okay? 20 IC. That is equals to, I have minus 12, so that when this minus 12, and let me check it. So that voltage will be 12 volt. If we take this one into that side, it will be 12 volt, okay? Okay, so now what we need to do is we can create in a form of matrix, okay? So we can create this way. So IA, I have 18, can write in here. Okay, and then IB minus 6. And then IC, I don't have anything on here, 0. And then on here, minus 6 IA. This then 16. And then minus 8. And then on here, IA, I don't have AA in here, so that's 0. On here, IB, I don't have any, minus 8. And then IC is 20. Okay, that is equals to voltage wise. So that's this that I can do. Then that means we have to multiply this one. I have multiplied this one by IA, IB, IC, because we just make in this form basically. IA, IB, IC. How does this do? So if I multiply IA times, like in matrix, we have to go this way, okay? IA, sorry, 18 times IA, which is 18 IA, minus 6 times IB, minus 6 IB, 0 times IC, which is 0, we don't have anything, okay? And then on here, minus 6 times IA, I'm just checking, minus 6 IA, 16 times IB, 16 IB, minus 8 times IC, minus 8 IC, okay? Similarly on here, we don't have any IA, so 0 times IA is 0, minus 8 times IB, minus 8 IB, 20 times IC, 20 IC, okay? So this is now in a current form, okay? So this represent this one, okay? From that, it means that we can apply matrix inversion, okay? Inversion. Okay, how do we do this one? Well, that is to find in order to find the current vector, okay? Well, if we look on here, the steps, we still so we restructure this one. Now we can use matrix inversion to find the vector current, okay? Step 3. The aim is to find the Thevenin first, okay? Okay, so now, well, I hope you can do the matrix inversion, but if not, we can try, okay? I'm just plugging my socket. Okay, now if we see here, IA, the phasor, the phasor, whatever, IA or the vector, IB, IC, equals to matrix inversion is in the form of this. We bring this one 8 minus 6 0 minus 6 16 minus 8 0 okay minus 8 20 okay inverse matrix times minus 8, which is the voltage in here, 6 volt and 12 volt. Okay, so what does this mean is it's just like current times the voltage, okay, or inverse current. Okay, so if we have to do this one, it will give us a solid answer, but I think I'm suspecting that I'm not sure if we be able to do this matrix inversion. Let me give you some explanation about this. Okay, so for example, if for example to do matrix inversion, we need to follow the 3 steps. Okay, the steps. Step 1 is calculate determinant of the matrix, and the step 2 we have to calculate the cofactors, and then from step 3 we can calculate the matrix inversion. Okay, so I'll give you a hint to calculate the matrix inversion. Okay, let's rewrite the in the determinant A is equals to, for example, if we say this is 18 minus 6 0 minus 6 16 minus 8, okay, and 0 minus 8 20. Okay, you can check this one in here, which is this one. Okay, and from that, step 1 is we need to calculate this one into determinant. So determinant is equals to, we have to do this way. If, for example, like we have to minus 6 16 minus 8 0 minus 8 20. Okay, so if we want to find determinant A, okay, that is 18. The first step is 18, for example, for this one 18 times, so that is 18. So for that one I have to do this way and then do this way. Okay, so that I have to write these 2 equations. Okay, that is 16 minus 8 minus 8 20. Okay, and plus, then the next step is 6 minus 6. Okay, the determinant is the top 3 minus 6 times, then if this is minus 6, then I have to this and then this. Okay, then I can write this and this. Okay, so minus 6 0 and then minus 8 20. Okay, and then I have 0 in here plus 0 times. Now if I have to this 0, I just do this way and that one, so that I can write this too. Minus 6 0 minus, sorry, 16 and minus 8. Okay, now what we can do is we can apply the notations. Okay, so for example, I can, this kind of notation, plus minus plus, because it's in matrix, minus plus minus plus minus plus. Okay, plus minus plus minus plus minus plus minus plus, or in downstairs in top to bottom, plus, minus, plus, minus, plus, minus. Okay, so now in here, I can start plus, plus, minus, okay, and then plus. So that means this is 18, okay, no problem. There's mixture difference, and then on here it is again plus 6, okay, and then on here it doesn't matter, it's 0. So let's do this way then. So 18 times 16, now I can do this crisscross. 16 times 20, okay, minus 8 times minus 8, which is 64. So this times this minus 64, okay, that is, I can write like this, 16 times 20, okay, create a small bracket, minus 8 times minus 8, okay, then I close the bracket for this one, then plus, because minus minus plus, okay, and then on here minus 6 times 20, minus 0 times minus 8, okay, then I close this one, plus 0 times minus 6 times minus 8, minus 0 times 16, close to, okay, so from that 18 times this will give how much? 4608, okay, and then plus, obviously. So in here minus 6 times 20, that is minus 120, okay, so and then sorry, I forgot on here 6 in here, so minus 120 times 6 is 720, but now this time it is minus, okay, because it is 6 times, so this is minus, okay, just minus put on here, because this minus 20, 120, so times 6 is minus 720, okay, plus, obviously this is 0 because 0 times, so that this will be 3888, okay, so determinant A equals 3088, okay, 3888, okay, so now step 2, so assume this is step 1, step 2, we need to find out adjacent or cofactors. Sorry, just need the eraser. I just need to put adjacent A. Okay. So we know that we have already calculated determinant A, and now we need to do the 2 times 2 determinant, okay? Why? Because if you look on here, the formula we try to follow is this. We have already calculated now determinant, now we need to calculate this adjacent, okay? From that, we have wrote this equation, okay, this table, sorry, and what we could do is now, if we have to do this first one, okay, top one, we can just the same do this, cancel this one and this, so that it will be 16 minus 8, and then minus 8, 20, okay? So the 2 by 2, so it will be, let me just, just need more space. Okay. So I just adjacent that is 2 times 2 matrix 2 by 2. Okay. So let's do it together now. So if for the top one, I'm going to cancel this way and then cancel down, so that the 16 minus 8 and the minus 8 and 20. Okay. This is this, and the next one is the minus 6. So that cancel the middle one and then this one. So minus 6, 0, minus 8, 20. Minus 6, 0, minus 8, 20. Okay. And then the last one is on the 0. Cancel this down, which means this down and that one. So that minus 6, 0, 16, minus 8. Minus 6, 16, 0, and minus 8. Okay. Okay. From that, then if for this one, then for that one, so we can just do this way and this one, so that this and this, this and this. Okay. So that will be minus 6. This minus minus 6 and minus 8, minus 6 and minus 8, 0 and 20. Okay. And the next one is the middle. I mean, this one is to find this one, this. Cancel that one and this one. So the minus 6, 0, minus 8, and 20. No, actually, sorry. So this one, the next middle, this one, it will be this and that one. So that 18, 0, 0, 20. Okay. So 18, 0, 0, 20. Okay. And then the last one on here, the middle of the last one is then this and that one. So that 18, 0, minus 6, minus 8. 18, 0, minus 6, minus 8. Okay. And now the bottom one now, this is then like for this to get this one, then cancel this and that one. Okay. So then all right, this one we left. So that for that one, this and this, minus 6, 16, 0, minus 8. Minus 6, 16, 0, minus 8. Okay. And then now for this one, we close down this one. For this one, cancel this one and that one. Then it will be my 18 minus 6 and 0 and minus 8. Okay. 18 minus 6, 0 minus 8. Okay. And then the last one, this one, close this one and that one. So that 18 minus 6 minus 6, 16. 18 minus 6 minus 6, 16. Okay. Now again, we need to apply the notations, that is plus, minus, plus, minus, minus, plus, minus, plus, minus, plus. Okay. So if on the top one, for example, we can apply plus, minus, plus. And then on here, minus, plus, minus. And then on here, plus, minus plus. Okay. So from that, we can just do the calculation as what we did for the determinant. Okay. So for example, 16 times 20 minus 8 times minus 8. Okay, that will do. Okay, I'm gonna show you like this. Okay, so when here like this times this minus this times this, it will be okay, and then minus, so minus this times this minus this times this plus, because this is plus, this times this minus this times this, so that will be 2. Okay, let me just get my calculator. Sorry. You have to use your calculator. So if we check 16 times 20 minus 8 times minus 8, that will be 2. Okay. I have so what we have is I've got is that minus 64. Okay. Sixteen times 20. Okay. So I have here 256, and then if I do this one, minus 6, so minus 6 times 20, which is 120. Okay, minus 120, and then minus 0, minus 120 times minus, which is 120. Okay, 120. I'm sorry, I have to make a nice space for this one. Let me just expand this one. Get a pen. 256 for the first one, and then for this one it is 120 and minus 6 times minus 8, which is 48, minus 0 times 16 is 0, so 48 in this case. Okay, and then on here minus 6 times 20 minus 120. Okay, minus 0 times this one is 0, minus 120, and then I have minus in here, which will be 120. Okay, and then on this one 18 times 20 is 360, because this is 0 if we subtract 0, so 360. Okay, and then on here 18 times minus 8. Okay, it is 144, minus 0 is 0 obviously, so minus times minus will be plus, so that is 144. Okay, and then on here minus 6 times minus 8, which is positive 48, minus 0 is 0, so positive 48. And then on here 18 times minus 8, which is 144 again, minus 0 0, so minus 144 minus times minus will be plus, so 144. Okay, and then on here 18 times 16, which is 252, minus 36. Sorry. No, 18 times 16, okay, minus 36, or minus 6 times minus 6 is obviously positive 36, then 252. 252, okay? So we now have adjacent, okay? From that, what we need to do is step 3. So we have determinant, we have adjacent, so we need to do the inverse matrix, or inverse matrix. Okay, so inverse matrix is minus A inverse equals 1 over determinant times adjacent. Okay, now is equals to 1 over determinant A times adjacent A. Okay, so 1 over 3,888 times, I think it's 256. If you look on here, 256, 120, 48, 256, 120, 48, okay, 120, 60, 144, okay, 120, 60, 144, okay, and the last is 48, 144, 252. 48, 144, 252. Okay, close this one. All right, so now we need to transport the matrix in order. Okay, so we've done this one now. Okay, and well, we could do this ordering, but after that, what we can do is then, if we do this way, okay, then we'll get IA, IB, IC is equals to okay, let's do this way then. 256 divided 3,888, that will be 0.0658, okay? And if I divide, so we have to divide each of them this one basically, then we will get 120 divided by this value again, it is 0.0309, okay? And then if we divide 48 by this value, then it will be 0.0123, okay? And then 120 divided by this value again, it will be the same value as as what we divide this one, then it'll be 0.0309, and then if I divide 360 divided by 3,888, it will be 0.0, you can do by calculator, guys, 926, okay? And if I divided this 144 divided by this value, it will be 0.037, okay? And if the last one is 48 divided by this value, which is 0.0123, and 144 divided this value, it will be this 0.037, and then 252 divided by 3,888, it is 0.0648. Okay, now this is now the in form of the current or the matrix times times the voltage now, if we have to apply, sorry. Because we try to find the vector current. Okay, so we need to find -8. We need to put -8 volt. I have here 6 volt, and then I have 12 volt. Sorry, 12 volt. Okay, so from that, if I multiply, so for this result, okay, we have this table. Okay, so which is the inverse of this one. This all is a to -1. Okay, so basically what we try to do is, if we look on here, it is a -1 times the voltage, okay, to find the vector currents, okay, phasor current, sorry. Okay, now we have calculated this value, and then we need to multiply by the voltage to find this phasor currents, okay, and then this will be this times this plus this times this plus this times this will be minus 0.193, okay, and then the second one, this times this, it will be 0.753, okay, and then the last one will be 0.9 9101, sorry, okay. So this is now amp, because we try to find the current, okay. Okay, now we found the current IA, IB, IC. That is the mesh current, okay. Easy, but time consuming, isn't it? So now our question is, what is Thevenin? Well, if we look now, we managed to find the current IA, IB, and IC. Now Thevenin is across A and B. So Thevenin is, we have 18 volt, and we have another, we need to find the voltage drop across here as well. Because we know the current IB in this current coming this way. IB times 2 volt plus the voltage 18 volt, isn't it? Okay. So that is 2 times IB plus 18 volt. Okay, that is 2 times IB is this one, 0.753 plus 18, which is 19.51 volt. Okay, so Thevenin across AB, across A and B, is total. So if this is A and B, 2 ohm, 18 volt. So this plus this voltage across this resistor will be equal to 19.51 volt. Nearly. The final question is, how do we calculate Thevenin? Well, Thevenin, we've said that we need to remove the voltage source and replace by the short circuit. And if we have current source, remove it and leave open circuit, okay? Now, look this way, okay? We have no current source, but we have voltage source, okay? So what we can do is this. We can just, let me redraw first. just redrawing, sorry, not the best drawing. Let's just eraser. Just okay. Another here is B. So we have this one. So now what we need to do is that short circuit the voltage source, each of them, just short, and then we need to calculate the R equivalent. Okay. So this is obviously 4, 3, 5, 6. Okay. And then here is 2 ohm, 6 ohm. What was this one? 8 ohm. Okay. So now the first thing what we could start is, I think we can start on this loop. So 4, because they are all in series, 4 plus 3 plus 5. 7 plus 5, 12. So and then we have 12 ohm on here, okay? Across this one. And then on here is short circuit. It's nothing here, no resistance. But sorry, we have 12 here, 12 ohm. From the circuit, we can check it, the original of the circuit. Sorry, this is 12 ohm in here. Okay. So this 12 will be in parallel with the 6. Okay. 12 will be in parallel with 6. So that means 12 times 6 over 12 plus 6. Okay. And then what else do we have? So that we have also this 12 ohm will be in parallel with this 8 ohms, isn't it? Okay, then 12. So this all together will be in parallel with this one. Okay, 12 ohm will be in parallel with 8. Okay, that means 12 times 8 over 12 plus 8. Okay, so let's do this way then. So this one is 12 ohm. This all together, okay? And 8 ohm is this one. Okay, and sorry. And then on here 12 in here, okay, 6 and 2 is here, 6. Okay, so now this 12 will be in parallel with this one, and then this 12 will be in parallel with this 8. Okay, so I have 2 here. So now again we can squeeze out, so we can multiply this and get this one, which will be R. Okay, so if 12 times 8 and 6, okay, now it will be divided by the 20. It will be 48, I think. Yeah. So it will be so for example, so as you can see here, this will be in parallel. Okay, this in parallel and that one in parallel in here. Okay, then we'll have equivalent of this one, and then the top one will be equivalent of this one. And then we'll have another here, this one. Okay, we'll have this structure. So assume now this is 96 divided by 20. That is, I think, 48. Okay. And then on here, 12 times 6, which is 72, divided 12 plus 6, 18. This is, I think, 4 ohm. Okay. So this is 48. And then this is 4 ohm. Okay. Then still 2 and 6 ohm in here. Okay. Then this again becomes, they all like this and this are in series. Sorry. 48 plus 4, which is 52. Okay. Now 52 ohm become in parallel with 2 ohm. And then this 6 ohm in series, A, B. Okay, so that this become again in parallel, that 52 times 2 over 54. Okay. Then we have to then find this equivalent and plus 6. Okay, that will be total of 7.6. You can check your calculation. 7.63 ohm. Okay, so R Thevenin, which is this one, A, B, will be 7.62. And then the Thevenin, obviously, we have already calculated 19.51. So we can represent 19.51. Okay. So if we have R Thevenin is equals to 7.63 and Thevenin 19.51, then Norton equivalent is equal, which will be, we can transform from voltage here, Thevenin, okay, into Norton. I can make this one into Norton current, and then the resistance, Norton resistance, will be in parallel, Rn. Okay. So that if this is now, sorry, this is R Thevenin, then I can find this one, I Norton will be V Thevenin divided by R Thevenin, isn't it? So that is 19.51 volt divided by R Thevenin, which is 7.63, and Rn will be the same as R Thevenin. Okay, so this will be, this current is this one, and this will be the same as this one. Okay, so R Thevenin is 7.62. Rn is equals to R Thevenin, which is 7.63 ohm, and Norton current is then 19.51 divided 7.63 ohm. Okay. Okay, thank you very much. So in summary, this is a bit lengthy, but very familiar way of doing this. So in summary, if we have to do Thevenin voltage, we need to consider, matrix if the equations are more than 2. Okay, if the equations are more than 2 equations, so for example, if there are 3, so we have to use the matrix form, matrix inversion current vector, and then from that, and a common way of doing the R Thevenin is obviously we have to remove the sources and replace them by short circuit if they are a voltage source, and leave them as open circuit if we have a current source. And then once we calculate the R Thevenin, just basically this is simplifying the resistors or making equivalent resistors to make it Thevenin resistance. Okay, and then after that we can model a Thevenin circuit using voltage and resistance in series, and then from that we can transform into Norton equivalent. Sorry, I have to Norton equivalent circuit. Okay, by transforming from Thevenin into Norton equivalent. Okay, how do we check this is in multisim? This is correct in multisim. Okay, well, we can check it. Let's have a look. So I built basically the circuit in here, as you can see. Okay, so the same circuit as it is built. So if we check it here, as you can see now, the voltage is the voltage across the Thevenin, across the total Thevenin across A and B. It is 19.51 or 506, 3 decimal point, which it matches with our calculation. So, and then if you see IA, mesh current A, minus 193 milliamp or minus 0.193 milliamp, I'm sorry. And then IB, if you see here, it is 0.901, IC, sorry. And then IB, it is 0.753 amp. Does it match? Let's have a look with this. Current, yeah, this current, okay. And then of course Thevenin is 90.51. That is 19.51. Okay, I think this is it for this session. Okay, so whatever we do is all the same. We apply either mesh current or nodal analysis, and then we calculate the Thevenin voltage, and then after that we can calculate the Thevenin resistance, and then from that we can represent the model and then do the source transformation to find the Norton equivalent. Okay, yeah, and that's it. Thank you for listening.